So hello guys. So today we will take a look at my pull request for PCSX Rearmed. Now last time we took a look at the HLE BIOS that I implemented like 2 years ago. But as you can see in the pull request, I did quite a lot. So the last one before me was fixing a crash in driver. But as you can see, the pull request after that are all by me. So let's take a look. So first one, internal database for problematic games. So uh, this adds an internal database for some problematic games, which for now only includes the memory card hack for codename Tenka. There is also a thin patch for codename Tenka, so it works over HLA too. This was tested on a PC. So let's take a look at the changes that I did. So first of all, we add the database file itself to the makefile. And then here's the juice, if you could say that. So how the database works basically is you have a huge array like this one, and this array contains the CD-ROM IDs for the game we want to patch. So in this case, Life Force Tenka, also known as codename Tenka. We then go through the array and we check for a match. And if we find a match, then we apply the hack. Now, for this game has a weird quirk. So let's say you have a real PS1. You have two memory cards in there, and you just boot up the game normally. What happens? The game will boot up normally, but when you get to the title screen, it will then ask you to remove one of the memory cards. Like, why would this approve? Like, it's just crazy. Like, what the fuck? So, now this could be because this is a game that was released in 1995. So probably Sony that tolerated that, but it was still strange. Or I believe they did it that way because they did not want to implement a memory card manager. So say you are the programmer of the game and you are on a tight schedule for the launch party, and you need to implement something that allows the user to select the memory card it wants to load or save the game from or to. Or you could just, like they do, uh, throw up an error screen until you remove one of the memory cards. You could do that also. So, basically, this avoids this annoyance for anyone that wants to play the game on PCSX Rearmed. And he approved. Now, initially, I also did that for an SPU hack that I did a while back for Diablo, but as you will find out later, I actually managed to fix this issue. So this was the original Diablo hack that I did 2 years ago. And if you take a look at it, it didn't sit uh it didn't sit quite well with me because as you can see, it's an extra condition, so that's wasted performance. So yeah, I didn't want to do that. So let's go back again to our other pull request. So the next one comes from another project called PCSX Redux. And PCSX Redux is basically PCSX reloaded but improved. Like they switched the code base to C++. I wouldn't call that an improvement, or whatever. But they also managed to fix some game-breaking bugs and some performance issues. So in this case, the DMA and marker was wrong. It wasn't not FF. It was actually 80000, because as they say, contrary to some documentation, the end of list marker is not actually FF. Any pointer with bit 23 set will do. And the funny thing is that this piece of code was actually implemented in the Unite plugin, but it wasn't done as such for the other plugins. So in our case, I had to fix, like, I believe in 3 places. So in the DMA code, they were using it as a duplicate from the plugins. Then we will fix it in the POPS code, the plugin code, and then in the GLS code, we will also use it. Now, I'm actually not sure if those pieces of code are actually used, but you know, I believe only the first one is actually used. And I couldn't find a regression from that change so far. So there's that. Now, here's the most important one. Well, one of the most important. So, the CDC in the PS1 behaves like in a strange way sometimes. So, say if you are pausing and then you then request you request a certain sector, depending on whether or not it is pending or not, the delay could be greater than if you were requesting it or not. So let me show you an example. So for instance, if you made a sector request, then it would set this. It would send location change to true. And whether or not you would play a file now, the seek times are actually multiplied by 30. Now, it's maybe less than that, but it takes more time. And some games are actually quite sensitive to that. So, in the case of PCSX Redux, delays reads after seek. So that's why they did as such. And in their pull request, they said it fixes dust spike in Xenogears. But it turns out that it fixed the desynchronization issue in the introduction for CTR. It fixed the FMV freeze in Final Fantasy VIII. It also fixed the Worms Pinball. So previously, before that change, the game would not even boot up. Like, it would just crash. Well, not crash, it will get you black screen. But after that change, the game finally booted. So yeah, he told me to make a few suggestions. So yeah, I didn't want to. Initially, I go over safe state compatibility, but I avoided that. So yeah, it actually fixed like 4 games or so. Quite fun. Now this one comes from another project. So PCSX For All. PCSX For All is the mixed variants of PCSX Rearmed. Actually, it's from PCSX Reloaded, but that's a long story. But anyway, they made improvements on their own forks, and I wanted to merge them, all of them, well, most of them, in PCSX Rearmed. So that's also one of the goals of my pull request. So, basically, one of the GTE registers, it was assumed that they were signed because of a hardware bug. However, the proper way of doing that is taking it unsigned and then implement the bug in the divided function. So if we'd say, but the sign extension issue was actually already implemented. But however, uh, it was still loading it as unsigned, so it was a bit of a waste. So I don't believe this fixed an issue with the game, but this is more correct according to the hardware, and there's no performance drop or issue, so he merged it really quickly. This one is important also because it fixed at least 4 games. It's possible that it fixed more games, but yeah. Basically, this fixes a mirroring issue in some FMVs. So, as you can see, in R types in the videos, they would get like a mirror issue in the first row of the screen. Actually, the first column, sorry. And there was a define that you could change to fix that. And I set it to 10. Now, in my original bug report, in the PCSX For All fork, they set it to 6. And if you set it to 6, it's indeed enough for odd types. But there was a bug report about Galerians. And Galerians was the same issue but much worse. So half of the screen was basically a mirror of the first row. And setting it to 6 was not enough because it was less worse, but there was still the first row that was mirrored. After setting it to 10, it looks properly. Now, he told me to check against the on direct, and I was able to confirm that they both behaved the same way. He then told me that 10 feels excessive, but I don't remember seeing any games with 50 or 60 FMBs. The PS1 probably can't pull that off. Maybe it's right. Who knows? And if we take a look at the PCSX Redux, they implemented it in a different way. And they don't actually use the MDEC bias. But after seeing that the code in PCSX Redux will have a greater delay, I was well, the value was greater than what we were using. I was afraid that it would incur a performance penalty without any explanation. So yeah, this way. So CHD support from LibRetros 4. Now, this adds CHD support to PCSX Rearmed based on the work of alias Spider for LibRetros 4. So CHD is basically you take a BinQ or BinQ files and you compress the CDA tracks as FLAC and you compress the data as LZMA to so basically you would get the best possible compression but without losing any without having losses. So for example, if you compress an uncompressed file and you compress it to MP3 or OGG, the audio would be in a compressed form, but it will be in a lossy form. So the CHD format is not lossy, it is lossless. So the gains may not be as great as lossy, but the upside is that you don't get a decrease in audio quality, but you still get a lower file size. So for a typical game that will use CDA tracks, the improvement can be from 30% to 50%. So it can be quite great. However, for your typical game that use XA music tracks, the performance benefits are more like 20 or 30%. It's still noticeable, of course, because a game can be 600 megabytes, so a 20% decrease is basically a decrease by 120 megabytes. So you could, so for say like one game that is compressed, you could have a small game that weighs that much. So, and if we take a look at the pull request itself, they use a library called libchdr, and this implements basically the code for reading CHD files. And as you can see, it's, well, it's still quite complex, but it looks neat, at least when you look at the pull request itself. And I implemented it as a submodule because the pull request in libretro, well, actually not that one, but the original pull request for the fork in libretros, they were not using a submodule. They were just bundling up all of the code and with all of its dependencies as well. And I wanted to avoid that, so I just added it as a submodule. And here prove my changes. So I also have to mention that the CHD format can greatly help on some platforms like the Funky. So say you have like a decent ARM platform, but the I/O speed is extremely slow. With a compressed format like this one, you would push less to you would push less bandwidth. Now, sure, you would still need to decompress it, but for the decompression, you would only need to decompress like say 4K. Like you only need to decompress in the buffer 4K because that's the size of the buffer. So effectively the overhead is quite small, but the benefits on some platforms can be great because of the slow I/O speed. So now again, this can be like sometimes this can be a great thing, sometimes it can be not. Like for example, if you take the example of some old DOS games, floppy drives are notoriously slow. So what people will do is compress the executable with UPX or something similar to speed up the loading times from the floppy drive, because it is faster to decompress the code itself or the data within the RAM and the CPU rather than loading uncompressed data from a floppy drive, because the floppy drive is slow. So that's why. And compression also allows you to bundle more uncompressed data onto one disk, but the downside, of course, is that you need to make sure that the compression speed is also good, because otherwise this can be a penalty for you. So alright, so the next pull request is actually a merge from another fork, so PCSX Redux once again. Now actually I should mention that they no longer use the HLE BIOS, but when they were still using it, they still made some fixes for it, and one of them is this one. So basically, instead of allocating a huge array for the HLE BIOS, it will limit it to the ones that are being used, and then catch the code and detect if it goes beyond what the array is, to avoid a buffer overflow, of course. And if it does, we just return null as it did before. Now, the benefit of that is to avoid some games that will try to make invalid BIOS commands and to avoid crashes. And I actually found a case that would just be that. So in Nuclear Strike over HLE, if you loaded a save, it will just do an internal crash of the emulator. Now, this is what the crash will do. Like, it will use the call info. It will then trigger an event. Then it will just poop itself. Like, it will just go crazy. So this effectively re-implements the original fix. Well, it wasn't a fix, it was more like an experimental patch. And now it's done properly. So I'm glad that I managed to merge that at least, because it actually prevented the game from crashing. Although I do have to say that in the case of this game, it still freezes. So, and when it freezes, you cannot exit the emulator, you cannot access the menu. But this is great for, say, detecting the true culprit for that game in the future. Now, I do have to mention that if you use like a Sony BIOS or the Open BIOS, it will work on that game. Now, this one is actually also a fix from PCSX Redux, and it was for PS Noob SDK games. So PS Noob SDK is an open source PS1 toolchain, and it's quite neat because previously people would use the official SDK to make their game, but that's problematic because that can be a legal issue and you cannot release the game as such publicly if you use the SDK. But with this, now the issue is that he was implementing the sound code in a strange way. He was basically well, I don't know, actually, let me find the original bug report, because there is actually a bug report about that. There we go. There we go. SPU init locks up in certain emulators in SPU control sync. But he actually makes use of SPU control sync, but the issue is that it's not implemented properly, and even the official PS1 emulator actually does not implement it properly because they actually don't make use of that. The original guy who made the fix, merely making SPU stat a mirror of SPU CNT would work. There's a small delay on hardware, but it's not very important to emulate. This should definitely work on real PS1 hardware. And he then mentions that the broken emulator is the official Sony emulator. So quite funny, really. And the fix is basically simple. Make a mirror. Emulate SPU stat as a mirror of SPU CNT. And I was able to test it against a game that actually uses the SDK, and that game would originally lock up during the loading screen, but now it's fixed. Now there is the infamous Diablo 1 SPU bug. So if you take a look at the bug report, which is now closed, the music was working until you talk to somebody or press start. Then it will get muted until the track loops or you press start again. So there was this nasty bit, and initially with the help of this guy, we just implemented a hack for Diablo 1. But we didn't like that actually. So I took a look at the PCSX Redux project, and I noticed that this function compared to the hack in Diablo looked quite different. So it had pstart. We didn't have that, although we did have we didn't have pstart, but we did have this one. Remember that one. And we also had ignore loop and new. And originally I would implement it in the same way as PCSX Redux would do. But he took issue with that because can you move this up a bit and make it a bit filled? Now the ignore loop I did as such, and I implemented it as a bit field. Then he showed me this because these are the ones that I use for PCSX Redux. I hope this can be avoided. Everything multiplies by 24 here, so you waste 99 bytes on here, which hurts slow devices with tiny cache. It would be a great way to avoid that, but whatever. And in the original comment, I said that pstart was taken from reg area later, and I said that this was a mysterious command. I then assumed that they were talking about this because I noticed that it was used. That it was used here instead of pstart as it was done in PCSX Redux. But if pstart was used here, then why did we have the issue? And the issue is that we should be doing none of that actually. But you still need to set the to set it somewhere, and it turns out that you should set it in sound main as it was done in PCSX Redux. And then we make sure to make it to 0 and implement the ignore loop flag. And the ignore loop flag is actually, from what I see, it's actually implemented in the hardware. I saw it in no cache documentation. So I wasn't initially sure about that, but it's actually a hardware feature. So yeah. So he made a suggestion, but it was wrong. It wasn't 14, it was 6, as I showed you before. Like, we shouldn't be using that one at all. Like, it has nothing to do with it. So that's why the hack worked, because this register, using this register for that is just wrong. And that's how we managed to fix the SPU bug and remove the hack for Diablo. So it looks good now. And I didn't get like a regression whatsoever because it actually fixed the bug in Diablo. So he then closed the bug report that you saw earlier. Now let's take a look at our next pull request. Rewrite GPU BIOS function according to OpenBIOS. Now, as I said before, OpenBIOS is basically a legal recreation of the PS1 BIOS. Now, previously, we had the HLE BIOS in PCSX Reloaded, which I have worked on and improved. But this isn't really the proper way of doing so. And it's an issue for other emulators because they can't really use that HLE BIOS. They have to re-implement it in their own code base. So the proper way would be to basically make a legal copy of that binary BIOS. And so that's what the PCSX Redux is basically doing. Now, the HLE BIOS in PCSX Reloaded was actually based upon the disassembly of the original PS1 BIOS by a Japanese user. However, not everything was disassembled. and the rest of it was pretty much guesses, really. And there was one bit of code that was really angering me, and it was that +1. And that could be an issue if you divide it by 2, because then the size could end up being different. So the proper way of doing that was just doing it as normal, and then just use a while, as it was done in the open BIOS. I also found that the pointer was not assigned 32 bits value, but it wasn't signed. And I also noticed that they were using GPU sync a lot more often, so I mimicked that as well. And if we take a look at the open BIOS, you would see like GPU sync much more often, and one of them would even use the return value. So that's what I ended up doing. So yeah, I don't believe it fixed the game, but you know, it's quite nice to have. This one is to fix a crash issue that will happen if you run the CPU test in Amidot. So this is basically the fix in a nutshell, and this is to avoid a potential buffer overflow when running the div function. But he told me that this was a potential performance issue on ARM platforms that use the interpreter, so it's only enabled for other platforms that are not ARM. Always look up verify dirty literals from offset by Neon Loop. So this was not actually my own patch. He used that patch from for the Trim UI handheld, because that handheld now runs PCSX Rearmed. So many thanks to them. And he fixed a bug that could cause a crash in Final Fantasy VII and other games. And he said literals are deduplicated, so there's no guarantee that they will be stored next to each other, even if they are written sequentially. So sequentially is you do one task, and when that task is done, then you go to the next one. Verify dirty and get bounce use the offsets on each instruction instead of assuming values are stored sequentially. Now, note that this does not affect the ARM-V specific code. This is only for the older kind of ARM. And so this is the original code. And now you can see like it does a lot more checks to make sure that it doesn't go overbound. Now, really, I don't believe that those asserts are necessary, but you know, I don't believe that this hurts it either. Now, this one is quite interesting. So there was a game called Blues Clues, Blues being musical. It's basically a kids game. And when you will play the FMVs will play, but you will get no sound. And I was like, how is this possible? Like, I was like, this could be anything. Like, this could be like a timing issue or whatsoever. Well, it turns out that this game actually have junk audio sectors, and for whatever reasons, they are ignored by the hardware. Now, in Mednafen, they originally had a code like that to reject 255 channel sectors, but they say that this wasn't the proper way because it was instead actually a timing and buffering issue in the CD-ROM code. But when I looked at Duckstation, they actually just reject that kind of audio sector, so 255. And if it is 255, then it is rejected. And you may also notice that this is not triggered if the XA filter channel is not 255, but I believe our code is doing that already, or maybe it's not, but whatever. I wanted to make sure that. So basically, if you reject junk audio sectors, they will play the wrong file, and the wrong file in our case being Nothingness, like, will just fail. This was tested on Blues Clues Beacon Musical, and it fixed the audio, the missing audio there. And Taxi 2 is also said to be affected by this, but I did not try that game, so I should mention that. So it fixed missing audio in a kid's game, so that's quite nice. So CDL sync should be null and return an error. This has been confirmed by both Mednafen and no cache documentation, see here in Mednafen. And CDL sync in Mednafen is just no, it's just nothing. But the issue is that we were not doing this properly. We were throwing an error, but not the right kind of error. Instead, it should throw invalid command. That's what it should throw. And Nola said about this function is, he said, you can make it fail if you like, but I would like to keep the name because Mednafen did not keep the name, they just used no. It seems the name came from debug code and symbols left in actual executable binaries and is probably what Sony intended, even if they later maybe removed CDL sync. Maybe, there is even an older hardware revision with working CDL sync. Who knows? In that case, I just kept the name, but make it fail instead, which is what I did. So one game that is said to be affected by this is Spyro 2. And if you don't throw an error for Spyro 2, it will actually just hang. Like in the intro screen, instead of going to the title screen, it will just hang. Like, so yeah, this is, it's actually Spyro, the PAL version, not the US version. So for the PAL version, it will do that. And Mednafen actually had that bug because they then fixed it that way. So improve set location CD-ROM command from Duckstation. I then show the code in Duckstation, and basically it makes sure that if it goes overbound or out of range, or if it is an invalid seek command or whatever, then it just rejects it. It doesn't try to set it to as it was set. Now, normally in most games, even if they were to do this, this would pretty much do nothing. But there was actually a game that if this was not implemented, then it would just crash. So let me see if I can find it. I believe, no, it's not that one. It's not that one. It is not that one either. Yeah, I actually can't find it. It was a change that was done in Duckstation, but I was able to confirm that this affects some novel, the Simple 1500 Volume 13, and this game will constantly trigger out of range seeking. But in Duckstation, this will make it so it suffers from audio delays, but this did not happen to us. So yeah, and we should be actually throwing an error, but we are not doing that. So maybe that's why it crashes for us. Who knows? don't throw an error for CDLQ. Now CDLQ in Mednafen is just use 1D, seriously, just that, and it returns 0, so it doesn't return an error. So we just make sure to not throw an error. It's that simple, really. But the other fixes are not so simple. So this one is quite baffling if you look at it. So CDL get mode is get param, fix it according to Mednafen's. So I have renamed CDL get mode to get param, the intended name, and changed the implementation to Mednafen's. So basically for get param, the result size should be 5 instead of 6, and it should be in this order. So it returns for the first 8 bits value status, and for the second one mode 0, filter file, then channel. In no cache documentation, it is implemented as such according to them and to Mednafen as well. So staff mode null, file, and channel. But our implementation was way off. Like, it was result size 6, which is incorrect. So there is potential to have a buffer overflow or for the game to misbehave. But thankfully it didn't, because it was just set to 0. So it didn't matter. And then, so we did basically mode, file, channel, 0, 0, and it was completely way off. Like, if a game was expecting it to have like file and channel, it will just get 0 and 0 instead. So yeah, completely way off. So in our case, it was stat mode, file, channel, null, null. So I fixed that and he merged it. And if we look at Mednafen, that's what they did. Status mode 0, file, channel. So it was quite simple, really, but it was quite a stupid mistake. But again, that's what happens when you have no hardware documentation, because the code base is actually much older than the no cache documentation or even Mednafen, by the way. Change get TD implementation according to Mednafen. So the get TD function basically looks like this. It returns status, minute, and second, all in BCD format. But if we take a look at how it was originally implemented, it was status, minute, second, and frame. However, as we were able to see, it doesn't return frame, so it should be ignored. So that's why we did that. Now there is, yes, that one. This one was also, it's probably one of the most baffling issues. So they confused reset and init. Like, what the fuck? Seriously. So let's take a look at my chain. So on the left is how it was originally implemented. So init was 10 and reset was 28. And yeah, they completely messed up. Like, if we look at Mednafen, we can see that the order is quite different from our original implementation. So it was reset in 10, and then it was init in 28. So they just confused the initialization command with the reset command. And that caused an issue because it prevented them from fixing a lockup issue in some games. So upon the reset command being issued, we need to set the mode to 20 as it was confirmed in Mednafen and disable the muting. We also changed the seek time for the reset command appropriately. And this fixed a lockup issue in This is Football 2 and Who's Party Game. So in This is Football, if the game will just have a black screen after the FMV intro. So you will not even get into the game. And if we take a look at Mednafen again, this is what fixed the lockup issue. And this only applies for the reset command. Now, this would still work if you do it in the init command, because the game would still make that call, but this is incorrect. This should be done in the reset command. And once that's done, it fixed at least these two games. So in Poo's 40 game, it would freeze after you select a character. If this is football, it would just lock up after the FMV. And it's quite funny because, you know, Poo's 40 game, it would lock up before it would show an FMV. And in this football, it would lock up after the end of an FMV. So yeah, I managed to basically fix like 2 games at least because of that. Now this one was probably one of the most painful PRs. So basically in Fantastic Pinball Q10 Kai, there would be this screen, then you select the memory card and black screen. The music will play, but the game will still lock up. And this game actually makes use of an obscure CDC command. And this obscure CDC command would basically return the current volume of the music of the CDJ track being played. And for some odd reason, the game actually relies on that. And if you get it wrong, then either it will lock up or it will sound delayed. So this is basically the algorithm that comes from Mednafen, and that goes over beyond my head. But basically, this should go through all of the frequency, all the samples, and then it returns the current volume of the track. So this is done like so yeah, and I should also point out that this is an unsigned an 8 bits value, and it returns value from 0 to 255. So this is for the left channel and the right channel. And it was quite painful initially because it actually needed this command, otherwise it would work, but you would still get the delay, and that was quite hard to find. So many thanks to Nothingness. But unfortunately, as he noted, it sucks having to do it this way though. It means CDDA reads are done 2 times needlessly. Perhaps play thread could be removed from CD-ROM ISO, and CD-ROM code would then take the job to send the CDDA audio to SPU somewhere in play interrupt. So instead of relying on that function, we would do it manually in a synchronous way in play interrupt. And we didn't do that, unfortunately, because I had no idea how to implement it. And unfortunately, I should have tried, because if not done this way, I actually found a crash on the font key. So basically, if you compress this game in CHD format, and then you will play that section of the game with the original code for the volume reporting, it will just crash in, guess what, guest function, in play thread. And what he said that should be removed, it was play thread also. So yeah, I probably would need some help on that because I wasn't able to get it right, but maybe I should try myself at some point. So yeah, a bit of a shame. So the next one is improve CDL Pulse command based on the implementation in Mednafen. So basically, if it finds if the drive is not ready, it returns a delay of 5,000. If not, then would it will just output what I call magic numbers, really, because the goal of the magic number is to make it work, but you don't know what it does, what it's how it was found, basically. And I kind of hate magic numbers because if you don't know the underlying issue, then you will encounter a game that will crash with that magic number, and you have no idea what could cause it. So yeah, I said in the original bug report that it allowed Worm's Pinball to boot more reliably to the language screen, but as it turns out, that it wasn't the case. It was just completely random. Like that game, unfortunately, is really sensitive to CD-ROM timing. Uh, so yeah, unfortunately, I found a bug, a regression even, from my pull request. So I'll say what I said. This is embarrassing. I found a bug within Mednafen related to this command, and it led to regression. I have reported the bug here. So basically, the bug is one game, Gundam Battle Assault 2, the European version of it, so PAL. The game will just hang like black screen. And in our case, it would actually just cause an internal crash, like not a crash of the emulator, but of the BIOS. So when it gets to that screen, it would then reboot back to the BIOS, and it just goes in a loop, like crash, uh, goes back to BIOS, repeat, and so forth. And you know, the reason why I was even able to guess that this was caused by this game was simply going through they actually mentioned that game, Gundam Battle Assault 2. However, this was the NTSC version by complete and no, it was really a coincidence because I was actually looking from the change logs in Mednafen. So I typed up that game in Mednafen and I stumbled upon the original bug report that was done last year. So this guy, so many, well, actually 2 years ago. So many thanks to that guy. So because I was able to find a bug report and basically broke the game. And so I found that the game actually worked in Duckstation, sorry. So basically what I did is that I just made the fix simpler. Now, the reason why I even did the Mednafen fix is because of one game, actually two games, so Rise 2 and Bedlam. Those games, if you don't get it correctly, if you don't get the pause and seeking correctly, you have graphical issues. And they were actually, and the fix was actually mostly done in CDL Pulse in Mednafen. But in Duckstation, it was not done in CDL Pulse because it was done earlier than that. It was because the code is asynchronous in Duckstation. So they had to implement it that way. So for now, I just did it the way that Duckstation did. And it fixed the lockup issues and all of the free games that were mentioned on the source code, they also work in both PAL and NTSC. So for whatever reason, this CDL Pulse command differs, well, I'm not sure if it differs on the refresh rate of the screen or the slower clock speed on PAL consoles. So could be why. So yeah, this was CDL Pulse. Now let's take a look really quickly at the other changes that I did. So LibRetro, they made a threaded renderer. Now the reason why you want a threaded renderer is to say you have like a Cortex A7, but you have 4 cores and they are all very weak. Now previously in PCSX Rearmed, you have the main thread running the CPU code and the CD-ROM code and the graphical code and the SPU code. Later, they made the SPU code threaded, so it would use 2 cores, but the GPU code, the GPU rendering code, was still on the main thread. So this is basically what they did. They made sure that you could put the GPU related code on another thread. And I was able to confirm that it does actually improve performance, because the way I did so was run the PC build and then just use fast forward. And if you show the FPS in fast forward mode, this should show you how fast your computer can emulate the game. And with the threaded renderer, I was able to gain about 13 FPS in Yu-Gi-Oh! So it was 220 FPS instead of say 114 FPS without the threaded renderer. So quite neat, and it's a lot of changes functionally, but you know, that's nice. There is the iCache emulation code as well. Now the iCache is the instruction cache of the PS1, and without proper emulation of the instruction cache, it was found that some games will actually misbehave. So F121, well, 2001, sorry, the game would work, but then when you go in game, the car would just go like crazy. Like you would go super fast, the car would jump around like crazy, and so on. And there's that, and there is some games that will not even boot up without that. So F1 Arcade locks up after the loading screen. F199 locks up after loading screen, and so on. So so basically this handles all of that. So yeah, the heart of the instruction cache emulation is basically this. I'm not really sure what it does, because it was actually taken from PCSX Redux, which itself improved upon PCSX Reloaded, because they actually had even during that time some code to for the instruction cache. Oh, and I should point out that it should be allocated in the heap, because if you do it in the stack, so this code should be allocated in the heap. In PCSX Redux, it was allocated in the stack, and I actually found that it would cause a crash if it was allocated in the stack as opposed to the heap. So for the heap, you actually allocate the memory with something like malloc, for example, like here. Whereas in the stack, you would just predefine at compile time the size of the array. So for example, you see int cycle, it would be done that way. So just wanted to mention that. And I really want to go real quickly, because all of the other fixes are irrelevant. So fix for Sim Theme Park internal crash. The game requests a resolution of 320 by 176 pixels for the FMV videos. However, the limit for the height was 199. This incorrectly resulted in the code adjusting it for 192 eventually triggering an internal crash. So the game was requesting a resolution, but the emulator was readjusting it improperly, and then it would just cause an internal crash in the GPU code. Actually, it would cause a crash in SDL itself, because it would then leak memory. So what I found was there was this weird bit of code that was like, again, that's a magic number, y 199 100, sorry, and 92, because this game actually goes below that, and in theory you could go even as low as 4 pixels. So this will need some hardware test, because I believe the way they detect the GPU size is from a GPU command. So I've been told that this command was actually dips and dot screen structure. So using that structure, if you set it to a certain size, then it will tell the GPU plugin to set it according to that size. But unfortunately, that means that games can basically do whatever they want size-wise. Well, not really. Maybe they have a restriction on the width, but not maybe on the height. So yeah, so that game, if that is merged, it should work on the software renderers. Now, this does not happen on the OpenGL renderer, because the crash never happens. So even though it leaks memory, the allocated buffer is big enough to make sure that it doesn't leak memory, so it doesn't crash. So that's pretty much it for it, guys. So I hope you enjoy my improvements, and I hope it will benefit all of your low-end devices. So thank you and bye.